Welcome to the DIY Honda Garage channel. DTC P0453, known as the FTP sensor circuit high voltage issue, directly pertains to the fuel tank pressure FTP sensor functionality in the Honda Fit models from 2015 to 2020. The FTP sensor is critical for diagnosing fuel vapor leaks and ensuring the effectiveness of the vehicle's evaporative emissions control system. It is located on the top of the fuel tank, connected to various components that facilitate accurate emissions data to the powertrain control module, PCM. A malfunction in this sensor can lead to improper fuel system pressure readings, which will illuminate the check engine light on your dashboard. It's important to identify this fault quickly to maintain vehicle performance and compliance with emission standards. The Diagnostic Trouble Code indicates that the voltage detected by the FTP sensor circuit is higher than expected, prompting further investigation into the sensor, wiring, and connections to pinpoint the exact cause of the fault. The DTC P0453 refers to the FTP sensor circuit high voltage, which typically indicates that the signal voltage from the FTP sensor is above the normal operating range of more than 4.7 volts. The FTP sensor plays an essential role, measuring the pressure within the fuel tank to detect vapor leaks effectively. This sensor is housed within the fuel tank, suggesting that accessibility may require fuel tank removal for detailed inspection. Its location ensures that it can accurately monitor gas vapor levels and send necessary information back to the PCM, allowing for the appropriate management of fuel emissions. Malfunctioning of this sensor may lead to the vehicle failing emissions testing due to incorrect readings of the vapor pressure inside the fuel system. Therefore, understanding its role is vital for effective troubleshooting. The potential causes of DTC P0453 include a faulty FTP sensor, which may be providing inaccurate voltage readings due to internal malfunctions or wear over time. Additionally, wiring issues can contribute to this fault. Damaged or frayed wires leading to the FTP sensor might result in inconsistent voltage transmission. Furthermore, poor connections at either the FTP sensor or the PCM can lead to high voltage readings as electrical resistance increases. Visual inspections of the wiring harness and electrical connectors are crucial in diagnosing the problem accurately. Keeping in mind that intermittent failures can also occur, it's essential to replicate the conditions under which the DTC was set to ensure a thorough analysis. Common symptoms associated with DTC P0453 include the illumination of the check engine light on the dashboard, which alerts the driver to a potential issue within the vehicle's fuel management system. Additionally, drivers may experience poor fuel economy as the engine attempts to adjust for inaccurate pressure readings, leading to inefficient combustion. Increased emissions are another likely symptom, as the faulty sensor could contribute to improper fuel vapor management, triggering failing emission tests. These symptoms may not be immediately recognizable, but they can lead to significant long-term maintenance issues if not addressed. Therefore, it is vital to take these warning signs seriously and conduct timely diagnostics of the FTP sensor system. In the initial step of troubleshooting for DTC P0453, the vehicle should be set to the on mode, allowing various electrical systems to power up for diagnostic checks. Following that, the specific diagnostic test equipment, Honda Diagnostic System HDS, is used to clear the DTC. Clearing the DTC helps refresh the error log and enables accurate assessments in subsequent steps. After clearing the DTC, the next task is to remove the fuel fill cap, which serves as a necessary step to assess the FTP sensor accurately. Removing the cap allows for the evaluation of the evaporation system's current conditions. which is critical for determining if the sensor is functioning properly. The conditions must be checked with the HDS for signal values exceeding the malfunction threshold set at 4.7 volts. The second troubleshooting step requires that once the fuel fill cap is reinstalled, the engine should be started and maintained at a steady speed of 3,000 revolutions per minute, RPM, without load. This process is crucial as it simulates operating conditions while allowing for thorough monitoring of the FTP sensor's performance. Holding the engine at this speed until the radiator fan engages is critical for ensuring the ECU has sufficient data to assess normal operating conditions. During this time, the Honda diagnostic system should be utilized to check the onboard diagnostics (OBD) status for DTC P0453, indicating if the sensor's functionality is consistently high voltage or if it has temporarily reverted to a normal state. If the HDS indicates a failed status, it leads to confirming the failure for further diagnosis. In this step, the initial action is to turn the vehicle off to ensure safety while disconnecting the FTP sensor 3P connector. This connector links the FTP sensor to the PCM, and removing it facilitates direct testing of the sensor's signal output. Using a jumper wire to connect terminals A and B, located on the FTP sensor connector, simulates a controlled condition for precise voltage measurement. With the vehicle back in on mode, the HDS can now be utilized to check for signal parameter readings that should again exceed 4.7 volts. If the reading is appropriate, it indicates that the sensor is likely functioning correctly, whereas a reading lower than the threshold would necessitate replacing the FTP sensor. The fourth step involves a detailed voltage measurement taken between designated test points while ensuring the FTP sensor 3P connector remains disconnected to avoid erroneous readings. Specific test points 1 and 2 correspond to the FTP sensor terminals, where voltage levels should be assessed with the vehicle turned on. The expected voltage in this step is approximately 5.0 volts. If the measurement meets this condition, it indicates that the forward wiring from the FTP sensor to the PCM is intact, allowing further diagnostic steps to progress. Conversely, if the measured voltage is not within the specified range, it suggests potential wiring issues or other faults that would further need to be addressed in subsequent troubleshooting steps. This step focuses on performing an open wire check on the P-tank line. The vehicle should first be turned off to ensure safety before jumping the SCS line with the HDS, a procedure used to discharge the system safely. The next move is to disconnect the PCM connector B51P to gain access to the necessary terminals. A jumper wire is then used to connect terminal A of the FTP sensor 3P connector number 2 to body ground, which allows for the continuity check between designated test points. The test circuit involves checking the connectivity between the PCM and the FTP sensor, ensuring that all wires connecting them are robust and free of breaks. Achieving continuity would suggest that the wiring is intact. However, if continuity is not established, it indicates an open circuit within the P-tank wiring that requires repairs. The final step involves assessing the SG5 line for possible continuity issues. Like previous steps, begin by disabling the vehicle's electrical systems by turning it off. Then, similarly, jump the SCS line using the HDS to allow for safe testing. After disconnecting both the FTP sensor 3P connector and the PCM connector A, 51P, a jumper wire should connect terminal A of the FTP sensor 3P connector number 1 to body ground. The next task is to check for continuity between the specified test points in the SG5 circuit. If continuity is confirmed across both test points, it suggests that the signal line is intact, and the next step would involve updating the PCM software or potentially substituting a known good PCM to resolve the issue. If continuity is absent, it serves as a strong indicator that there is an open wire that needs immediate attention. After completing the diagnostic and repair steps for DTC P0453, it is essential to verify that all repairs have successfully restored system functionality. This involves conducting a final check of the FTP sensor's operational status and ensuring that there are no recurring error codes. Running the engine and allowing it to reach its normal operating conditions facilitates this verification process. Careful observation for any signs of the check engine light re-illuminating post-repair is also pertinent. It's crucial to confirm that the previous faults have been addressed effectively to ensure emissions compliance and optimal vehicle performance. Proper verification will not only foster confidence in repairs, but is also vital for customer satisfaction and long-term reliability of the repair work. Implementing preventive maintenance practices for the FTP sensor system is essential for avoiding future occurrences of DTC P0453. Regularly testing the functionality of the FTP sensor, along with periodic inspections of connected wiring and terminals, can help identify potential issues before they escalate into significant failures. This proactive approach ensures reliable readings from the FTP sensor, a critical component that can significantly affect emissions control. Additionally, regularly updating the PCM software to the latest version is vital, as manufacturers often release updates to improve compatibility and rectify previously identified bugs. This blend of regular maintenance and system checks will promote longevity and peak performance of the vehicle's evaporative emission control system. In summary, DTC P0453 signals high voltage from the FTP sensor, which can indicate a malfunction affecting crucial emissions-related parameters. The FTP sensor's role in monitoring fuel vapor levels is critical for adhering to environmental regulations and ensuring optimal vehicle operation. Each troubleshooting step provides a comprehensive approach to identify the faulty component, whether it be the sensor itself, wiring, or connectors. Prompt diagnostics and repairs can often prevent more severe issues later on, ensuring both vehicle efficiency and compliance with emission standards. It's also essential to follow additional preventive maintenance procedures to keep the FTP sensor system functioning correctly in the long term. Ultimately, understanding the intricate details of these systems enhances both vehicle performance and driver confidence. Please like and subscribe to the channel. See you next time.